Dear students, I, Aarti Rani, from School of Computer Applications, Babu Banarsi Das University. Today I am going to discuss with you the IoT and sensors. So in index, first of all, we will discuss about the IoT, then next components of IoT, then sensors, types of sensors, and sensor networks. Introduction to IoT. The Internet of Things describe physical objects embedded with sensors and actuators that communicate with computing system via wired or wireless networks, allowing the physical world to be digitally monitored or even controlled. The Internet of Things is a technology that allows us to add a device to an inert object. For example, vehicles, plant, electronic systems, roof, lighting, etc. that can measure environmental parameters, generate associated data, and transmit them through a communication network. So IoT refers to the physical and virtual objects that have unique identities and are connected to the internet. So this allows the development of intelligent applications that make energy, industrial control, retail, agriculture, and many other domains of human endeavor smarter. So IoT allow different types of device, appliances, users, and machine to communicate and exchange data. IoT empower business to make better decisions by providing them with real-time and actionable data. With IoT device and sensor deployment throughout various processes, businesses can collect and analyze vast amount of data, allow for a comprehensive understanding of their operations. So an IoT system consists of sensor devices which talk to the cloud through some kind of connectivity. Once the data gets to the cloud, software processes it and then might decide to perform an action, such as sending an alert or automatically adjusting the sensor device without the need for the user. This diagram shows the major components of IoT. So in this diagram, things or IoT, gateway, cloud, analytics, or user interface, these points are the main components of IoT. So things or devices, these are the fitted with sensor and actuator. Sensor collect data from the environment and give to gateway, whereas actuator perform the action as directed after processing of data. So some commonly used sensors are temperature sensors, thermostat, pressure sensor, humidity and moisture level, light intensity detectors, moisturizer sensor, moisture sensor, proximity detection, RFID tag. So the first component is things or devices. Then second component is gateway. The sensor give data to gateway and here some kind of pre-processing of data is even done. It also acts as a level of security for the network and for the transmitted data. And the third one is cloud. The data after being collected to is uploaded to cloud. Cloud in simple term is basically a set of servers connected to internet 24/7. The next component is analytics. The data after being received in the cloud processing is done. Various algorithms are applied here for proper analysis of data. Techniques like machine learning, etc. are being even applied. The next component is user interface. User and application where user can monitor or control the data. Now the sensors. What is sensor? A sensor is a device that detects and responds to some type of input from the physical environment. The input can be light, heat, motion, moisture, pressure, or any number of other environmental phenomena. The output is generally a signal that is converted to a human readable display at the sensor location or transmitted electronically over the network for reading or further processing. So basically, sensors are devices that can measure or quantify or respond to the ambient changes in their environment or within the intended zone of their deployment. They generate response to external stimuli or physical phenomena through characterization of the input functions and their conversion into typically electrical signals. For example, heat is converted to electrical signal in a temperature sensor, or atmospheric pressure is converted to electrical signals in a barometer. So sensors are used for sensing things and devices. Here are some characteristics of a sensor. One is a static and the other is dynamic. Now the sensor classification. First, passive sensor cannot independently sense the input. For example, accelerometer, soil moisture, water level, and temperature sensor. The next is active sensor. Independently sense the input. Example, radars, sounder, and laser attenuators sensors. The next is analog sensor. The response or output of the sensor is some continuous function of its input parameters. For example, temperature sensor, LDR, analog pressure sensor, and analog Hall effect. So sensor is only sensitive to the measure property. Now the digital sensor is response in binary nature, designed to overcome the disadvantage of analog sensor. Along with the analog sensor, it also comprises extra electronics for bit conversion. Example, passive infrared sensor and digital temperature sensor. The next is scalar sensor, detects the input parameters only based on magnitude. The answer for the sensor is a function of magnitude of some input parameters, not affected by the direction of input parameters. Example, temperature, gas, strain, colors, and smoke sensor. The next is vector sensor. The response of the sensor depends on the magnitude of the direction and orientation of input parameters. Example, accelerometer, gyroscope, magnetic field, and motion detector sensors. Now the next topic is types of sensors. The first one is electrical sensor. Electrical proximity sensor may be contact or non-contact. Simple contact sensor operate by making the sensor and the component complete an electrical circuit. The non-contact electrical proximity sensor rely on the electrical principle of either induction for detecting metals or capacitance for detecting non-metal as well. The next sensor is light sensor. Light sensor is also known as photo sensor and one of the important sensor. Light dependent resistors or LDR is a simple light sensor available today. The property of LDR is that its resistance is inversely proportional to the intensity of the ambient light. When the intensity of light increases, its resistance decreases and vice versa. Next is touch sensor. Detection of something like a touch of finger or stylus is known as touch sensor. Its name suggests that the detection of something. There are two types, resistive types and captive type. Today, almost all modern touch sensors are the captive types because they are more accurate and have a better signal to noise ratio. The next one is range sensing. Range sensing concerns detecting how near or far a component is from the sensing position, although they can also be used as proximity sensors. Distance or range sensors use non-contact analog techniques. Short range sensing between a few millimeters or few hundred millimeters is carried out using electrical capacitance, inductance, and magnetic technique. Longer range sensing is carried out using transmitted energy waves of various types of like radio waves, sound waves, and lasers. The next one is mechanical sensor. Any suitable mechanical or electrical switch may be adopted, but because a certain amount of force is required to operate a Mechanical switch, it is common to use micro switches. The next is pneumatic sensor. This proximity sensor operates by breaking or disturbing an airflow. The pneumatic proximity sensor is example of contact type sensor. These cannot be used where light component may be blown away. The next is optical sensor. In their simplest form, optical proximity sensors operate by breaking a light beam which falls onto a light sensitive devices such as photocell. These are example of non-contact sensors. Care must be exercised with the lighting environment or these sensors. For example, optical sensors can be blinded by flashes from arc welding processes, airborne dust and smoke clouds may impede a light transmission, etc. The next is speed sensor. Sensor used for detecting the speed of any object or a vehicle which is in a motion is known as speed sensor. For example, wind speed sensor, speedometer, UDR, and ground speed radar. Next one is a temperature sensor device which monitors and track the temperature and give temperatures measurement as an electrical signal are termed as a temperature sensor. These electrical signals will be in the form of voltage and is directly proportional to the temperature measurement. The next one is PIR sensor for stands for passive infrared sensor, and it is an electronic sensor that is used for the tracking and measurement of infrared light radiating from objects in its field of view. It is mainly used for detecting human motion and movement detection. The next is ultrasonic sensor. The principle of ultrasonic sensor is similar to the working principle of sonar and radar, in which the interpretation of echoes from radio or sound waves to evaluate the attribute of a target by generating the high frequency sound waves. Actually, in sensors, the various sensors can be classified on the basis of power requirement, sensor output, and property to be measured. So the way a sensor operates decide the power requirement that must be provided for an IoT implementation. Some sensors need to provide with a separate power source them to function, where some sensors do not require any power source. Depending on the requirement of power sensor, they are divided into two parts, active and passive. So the sensor node is made of the combination of sensors. Sensor is a processor unit, a radio unit, and power unit. The node are capable of sensing the environment that they are set to measure and communicate the information to other sensor nodes. So sensor is a very important part of IoT. Without sensor, IoT is nothing. So all sensors can be defined by their ability to measure or capture a certain phenomenon and report them as an output signal to various other systems. However, even within the same sensor type and class, sensors can be categorized in a different manners. So sensing type, there are lots of types of sensors, and there are different sensing types. So I hope this is clear. Now the sensor network. A sensor network is a group of sensors where each sensor monitors data in a different location and sends that data to central location for storage, viewing, and analysis. There are many applications for sensor network, from monitoring a single home to a surveillance of a large city to earthquake detection for the whole world. So the first is home security. The primary goal of a home security sensor network is to detect an intruder. Many different types of sensors can help collect data towards that goal, such as magnetic open sensors on doors, windows, and glass break sensors, security cameras, and motion detectors. The next one is environmental monitoring. The researchers, farmers, and government need to monitor aspects of the natural environment, such as air pollution, water quality, soil conditions, and weather metrics. The traditional approach to monitor is collect a sample, bring it back to a lab, analyze, and record the result. Needless to say, that approach is slow and dependent on human labor. So traditional monitoring does not produce a lot of data. The next one is municipal surveillance. In a city, crime can happen anywhere, and with modern transportation, criminals can come from anywhere to commit crime in a city. Police officers cannot be everywhere at once. So, how can they track down the criminals that commit crimes? One approach is a network of surveillance cameras throughout the city, all linked together and sending video back to the police station. For example, the city of Chicago operates a network of more than 30,000 security cameras plus additional cameras in a police cars, boats, command vans. Some of the security cameras on the streets, highways of Chicago are also equipped with the automated license plate readers technology that snap a photo of a car license plates and convert the photo to be a textual representation. So massive database keep track of each license plate, where it been cited, whether it is associated with a stolen car, and if the driver has known warrants. The next one is earthquake detection. So ever woken up in the night from your bed shaking? If you leave near a fault line, your first thought might be earthquake. So when that happens, to immediately look online for reported earthquakes in my area. One way to verify my suspicion is with a search of local Twitter posts, but the more scientific way is checking data from the earthquake sensor network. So I think this is clear about the sensors. So thank you so much for this presentation.